Okay, so we're going to integrate x squared e to the 3x. So we set up u and dv. Those are the first two that we set up. And the choice for u is going to depend on choosing which of these two functions, x squared or e to the 3x, gets simpler. Think of it that way, simpler when you take du. And then after we do du, then we'll get the v. So my choice for u will be x squared, which then leaves e to the 3x dx is your v. Okay. So now x squared, when I take du, it becomes easier, and it becomes 2x dx. You must have that dx. That's a really important part of the step. So now to get v, I really am doing the antiderivative of e to the 3x dx, which is really a u substitution. U is 3x, so I have a third du is dx. So this whole thing, it's just the integral of a third e to the u. So some people after a while will get very fast at this, and they'll be able to put here what that answer is. So that is 1/3 e to the 3x. So basically it's uv, so it's 1/3 x squared e to the 3x minus the integral of v du. So the integral of 2/3 e to the 3x dx. And it's actually, I forgot the x there, so it's really 2/3 x e to the 3x. Okay, now looking at this, it's 2/3 x e to the 3x. So I've simplified from an x squared e to the 3x to an x e to the 3x. So I now have to do integration by parts one more time. So now I'm going, for this integral, I'm going to do u dv, and then I'll have du, and I'll have v equals. So our choice for u is going to be, I always put the constant with it. So I go 2/3 x. So du is 2/3 dx. And the dv is the e to the 3x dx. And you will notice in many problems that come along, you want to keep with the same dv throughout. That's going to make it easier. So now, in this case, v, we had already done the integral of that, and it is 1/3 e to the 3x. So we now have another integration by parts. So now we can say that our answer is, let's move this here, it is 1/3 x squared e to the 3x minus, and now I have to do the integration by parts on this integral. So I do uv, which is 2/3 times a third, is 2/9 x e to the 3x minus the product, the v du. So I need the product of those, which is 2/3 times 1/3. So it's 2/9 e to the 3x dx. And now what I have to do is I have to be careful about this minus being distributed through, and then work it from there. Okay, so now we're going to distribute this through, and so working this, we get that this integral is 1/3 x squared e to the 3x minus, we distribute that through, minus 2/9 x e to the 3x minus a minus plus the integral of 2/9 e to the 3x dx. So now, using what we had here, we're going to put a third in front of this. Okay, so working this out, this becomes 1/3 x squared e to the 3x minus 2/9 x e to the 3x plus, we've got the 2/9. Now we're going to put a third e to the 3x plus constant. Now normally that would be, we can just go through with the 2/9 and a third and work it through, but I do want you to see that that would be fine provided you make this 2/27. But the way the book sometimes does it, they factor out the e to the 3x and the common denominator, which is 27. So let me show you how we would do that. So this problem, what they would do is they'd factor out an e to the 3x and they'd factor out a 27 because that's the common denominator, and this would be 9x squared minus 2 times 3, 6x plus 2 plus a constant. And that's how the book will probably write it. It's okay for me if you leave it more in the upper level, but this is probably the most simplified way.